We are.
Sorry, that's not what it is. It's not very evident on MSLP. I mean, we're getting snow right now.
Okay, I think we'll get started with our discussion today. Thanks for coming. Very interesting weather around the hemisphere and around North America too. So there's a lot to talk about. We probably won't talk about all of it in the depth that some of you may wish, but you're more than welcome to throw out suggestions for what else to look at. Because, you know, I'll tell you the honest truth. It'd be nice if one or a couple of you decided that you wanted to do the discussion one week so that I could sit back and be the one who throws out suggestions. I'm open to that. So is Michael. We've been open to that for 25 years. And yeah, we don't have a lot of takers on that.
And you're not asking them to do the whole part, even just a 5-minute piece on something that interests you.
Yes. So yeah, that's right. I mean, this is the forum for interest in weather phenomena and climate phenomena, whatever it happens to be. So if you find something during the week that you really want to talk about, bring it in. Matt Hitchman does that a lot of times. He'll kind of come in and tell us about the ozone hole or something like that at this time of year. So it's perfectly okay to do that. But seeing no desires for the floor, I will instead go to our satellite picture over the continental United States first, Pete.
This one I think is up to date because it's
Okay,
from
this
the
looks
data
pretty good.
and
Okay.
stuff.
So we have over a large swath of the continental U.S. Maybe the exceptions are the southeast Atlantic coast and Florida itself. Clear skies, beautiful clear skies. We'll see here some snow in the high elevations of Wyoming, Montana, and Colorado. A little bit creeping into the plains too, and you can even see it creep away as the sun comes up, just fractionally. Maybe with a close-up, it'd be easier to see. A broad, not so clearly defined weather system in the south central states that's partly related to tropical disturbance 17, which we thought was named. It's got some interesting phenomena. Look at this thing racing down the Mexican coast with a line of convection on the front edge. Really, really interesting. And then a weak disturbance we'll see at sea level around the Red River Valley of Texas-Oklahoma border. And there's precipitation being generated along a line like this that's low-level phronogenetically influenced, and then the tropical cyclones. There's a combination of things going on in the southeast U.S.
Hey, John.
Yeah.
Is that strip that's in northern Texas, is that a band of snow that's accumulated snow?
Yes, there's snow in north and Texas Panhandle. So just I think Amarillo had snow, and then places north of Amarillo did. Did they?
Yeah.
How much? Oh yeah, Maggie, you know that's right. Yeah. How much did you say?
I don't know the.
Oh, okay. Okay.
It
Yeah, so
looks
snow.
like a decent accumulation in all pictures that sent to our crazy.
It's not fair. You know, I haven't seen a flake of snow yet, and it's already accumulated in North Texas. There's something really wrong about that. And Michael had the comment earlier today, just in private conversation, that perhaps this is not completely unrelated to the vapor transport anyway, from associated with the tropical cyclone. I don't know if that's true or not, but it's an interesting proposition. And certainly one sees this line of snow at high elevation until you get to North Texas, where the elevation is not particularly high. It's just downright cold. So that's interesting.
But in Colorado, though, I think that's Colorado Springs where you see a lot of it.
Right in here?
No, the one to the south.
Oh, further south, okay,
I
yeah.
think that's where they really got dumped on. It's
Yeah, okay.
More out on the plains.
Yeah, and I was looking at the Denver website, which is interesting in itself, the NWS website. I didn't even think to go to Colorado Springs. It'd be interesting to see what they reported. I was looking for some off, so we'll do that in real time. That'll be interesting to do. So that's the broad picture over the continental United States. We'll see some more details about what's really underlying the cloudiness just to our south and east, and then take a look more at the tropical disturbance as well. Mike will probably do more of that than me. And then we'll go out to the western, if we could, we go to the satellite picture on the west coast.
Before we switch that.
Oh, yeah.
And this is, I haven't looked at this carefully, and the Hurricane Center hasn't said much about it, but I'd be curious to, or just suggest that you follow what's going on in the central Caribbean, just south of Jamaica.
Right, yeah.
There's probably an easterly wave of some sort interacting with an upper trough. And this is the place in the western Caribbean where you can get big developments this time of year.
Oh, late
Near the end of the
October.
season, it's the Gulf of Mexico and the Western Caribbean. So that's just a place to watch.
Yeah, so maybe this will be
It looks
18.
innocuous. Yeah.
I don't know if well, you'll tell us. You'll see if it even shows up at all in the.
Just south of
Hurricane
Jamaica
Center map right
there, there's a circulation you can see.
now. I don't see it yet.
So the Carolina-
See the low levels there, you can see that over the western, more to the west and north.
Yeah, in that area
Right there.
Maybe an upper low. of some sort, but.
Okay, yeah, I think now that you pointed out, I didn't see that.
we may see-
All right, so there might still be some more tropical activity going on, so that's interesting. If we could go to the West Coast image or movie.
Infrared or what?
Let's do infrared, yeah, infrared.
Okay, so this one's gonna be old from last night until there's a jump there. 'Cause we
Yeah,
had
a little
data
bit
issue
jumpy.
tonight.
But the main feature that I'm interested in, and I'll show you some other piece of data from this one, is the storm at the end of the Aleutian chain. So you can see how well wrapped up it was last night. It still is a formidable disturbance, although not quite as well put together this morning as it was last night. And I'll show you some information from 0Z GFS run from last night, so more approximate to actually what we're seeing here in that stage of its life cycle. So that's an impressive disturbance. I think the sea level pressure is down in the 960s or 70s or something like that. There's cold air coming off the continent. As you can see, the open cellular convection here off the chain of islands on the north coast of British Columbia. That's about to change. It appears as though, in combination with a bunch of different developments, some of which will maintain cyclonic developments, not this particular storm, but a new one, and anticyclonic development off the west coast, will usher in some really remarkable warm advection to central Alaska and the Yukon Territory. They'll have temperature anomalies in the plus 10 or so range at 850 by 3 days from here. So it's going to be a really big development over the next few days at this longitude band, and we'll see a little bit of that perhaps in the forecast. One gets the impression, just from the high clouds visible in the infrared, that there is some sort of ridginess over the western part of North America. And we'll investigate that with some of these upper level charts in just a minute. Okay. So there's a lot going on around the continent, and all of this activity, big cyclone, big ridge, well, not so easy to see that sometimes, and then cyclonic disturbances over the eastern United States will be amplified over the next several days. So the flow gets very, very wavy in the western hemisphere, and we'll see that also in the forecast. I'll take a peek ahead to just those kinds of elements, and I'll leave the rest of the forecast to Mike. Okay, so let's take a look now at the radar over the continental United States, if we could, Pete. So here's the radar summary, and it's, as you can see, it's rather difficult to separate all of the different features I think we might start to see when we start doing a diagnosis of some of the precipitation and cloudiness that we've just been exposed to. There's a band of precipitation across New York State. We'll want to see how that's related to various other things. This is not so well structured in terms of linear bands or anything like that, but there does seem to be a northern boundary right about at the Ohio River. And then there's the cyclonic backside to this thing. It's clear that some of the cells within this western portion of the precipitation shield are rotating counterclockwise around some central circulation feature that might be in far southeast Oklahoma. So it looks like an extratropical cyclone, except that this is kind of a frayed looking region of precipitation in what would maybe canonically be the warm sector. It's wide and not so well put together. But don't forget, we've got a tropical disturbance number 17 right off the coast here of Texas. And so some of this is probably related to aspects of that circulation, and then approximate extratropical circulation to the north and northwest makes it not look particularly classical down over the southeast states, though it's raining heavily in a lot of locations. As you can see, the reflectivity is into the 50 plus dBz range over parts of Alabama, Mississippi, even Louisiana and Texas. And then we've got stray showers coming across the central part of the Florida Peninsula, carried by something more than the sea breeze. This is clearly a synoptic scale sort of circulation that's driving those cells across the peninsula.
And something about the rain over Mississippi, Alabama, and Georgia is that these are some places, particularly eastern Alabama and western Georgia, it's been really dry.
Oh, that's
so
right, yeah.
This is something that they're hoping they get more of. In fact, if this whole band of precipitation could shift maybe a couple hundred miles further to the east, this would be great news for some of those states.
I know Atlanta had an unusually high number of days over 90 for high temperature this summer, which was almost twice the annual average. And so that usually means that it's been a little too dry in the northern part of the state too, and that's true. So that's a little bit of relief for some of these people. Hopefully more to come. And then a little bit of echo in the Central Valley, but it's suspicious. I'm not sure this is really precipitation. This makes me think there's something else going on because it's confined to the valley. Maybe it's insects or smoke or something else, a combination thereof. And then a little bit of precipitation over the Pacific Northwest, and maybe not even reaching the ground. We can say when we see a surface map in just a second. Okay, and then we're enjoying a beautiful day again. Cold this morning. It's the first day that I was well below freezing at my house. I think I had 29 degrees, and so there was frost everywhere. First one for me, maybe not for everybody else, but it was the first one for me. So that's the season's begun, 25th of October. Okay, can we take a look at the large surface map, Pete? Yeah, let's zoom in first on our own location. So not surprising we got into the high 20s. The dew points are still in the mid to maybe high 20s as it stands. And so 45 over 27 with a light zephyr from the north. What a beautiful fall day. Maybe a little too cold if you don't have a jacket, but I mean, that's a small complaint. Dew points broadly, well, actually, we're in the driest patch in the entire central United States. The state of Wisconsin is a little to our west. The dew points are around 30, and a little bit to our east, the same thing. If we go down further south, we'll start to get into the rain that we saw. There's a couple of locations. Here's some heavy rain in southeastern Tennessee. I'm not sure of the station name. Moderate rain in Knoxville, right across the hills from North Carolina. Lighter rain to the east. Moderate rain in northern Mississippi. That's not Meridian, but it's close to it. Moderate rain in Jackson, and then lighter rain to the south. Heavy rain in New Orleans. So it's scattered, as you can see on the satellite. Heavy rain in southern Arkansas. And so a lot of places getting rain in the region that has been droughty. One can see that a couple of places anyway are getting rain, and that's one of the heavy rain spots in southeastern Tennessee. Nothing reported at the stations that are reporting on this map in Georgia. And you can see evidence of at least one spot in central Florida, a victim of one of those rogue showers coming across.
But that's a gross day. I don't know if it's Nassau. Look in the Bahamas, 88 over 77.
Yeah, it's 86 over 77.
86, okay,
yeah, that's miserable. It's in the 70s for dew points all along the Florida East Coast. It's actually the same in the West Coast. So the whole state has a dew point of about 70. The southern half of Georgia does too. And then, of course, New Orleans, 72 over 70 and a heavy rain. It's going to be soon 71 over 71, I'm guessing. And further to the north, though, in Louisiana, dew points are quite a bit lower, 56 degrees. So one gets the impression, here's the tropical influence, and further to the north, something more of the extratropical.
And you can see the cold convection off the coast.
Yeah, that's right.
Southeastern Texas.
Very obviously strong northwesterly flow with bone dry dew points comparatively in the 30s and low 40s. And strong winds everywhere, reporting 15 knots or higher across much of the state.
Is that a blue northern?
Might be. I mean, here's it's 35 over 26 where we saw a little bit of snow near Amarillo.
But you can actually see the snow impact right there. If you look at Midland, Odessa, 45 over
45,
26.
49, yeah,
And then
same
to the
dew point.
northwest, it's even warmer. So
That's right. So there's local temperature depression because of the snow. It goes into western Oklahoma. So
and the dew point effect too, from maybe sublimation. You can see it's a little bit higher in that band.
Yeah, right. That's right.
Than the northwest.
Yeah. Very interesting.
Different kind of miserable day in Oklahoma. 42 over 41 with rain.
Yeah, that's right.
39 over 35.
Probably not something they get that often in October, but trying to find the center of the circulation too. The lowest pressure is very high. The lowest pressure I see, well, now we're getting closer to the tropical cyclone, but maybe in the region of the circulation, it's about 1,019-ish millibars. So it's not a deep cyclone. It's not really a very well organized feature at the surface level. But there is a broad region of precipitation and a lot of interesting mesoscale characteristics to it, particularly the snow in North Texas. I don't want to talk about that anymore. It's frustrating. Let's go to the West Coast, if we could, on this map. I think what we'll see here is that in certain locations at high elevation, maybe we won't really see it. Here's one right here, 65 over 5 with a 20-knot wind from the east. That's a gap in the mountains, is my guess. Bone dry dew point, the air is subsiding. It's dry all along the coast. This is a characteristic of the Santa Ana time of year. The pressures in the interior are a lot higher and a lot lower on the coast. They're in the 1,016 to 1,020 range on the coast, and they're at 1,032. It's 1,030 at Great Salt Lake. The highest pressure I see is 1,032.2. I think that's Ogden, Utah. So 1,030-ish in the interior of the Intermountain West, and 1,020 on the coast. And it's actually 1,025 right here in the California Nevada border. And so like this example station, I don't wish I knew what it was, probably flow through a gap. And that's exactly the kind of thing that can enhance the fires that might start naturally because of the prolonged dryness of the summer. Okay, in a couple of spots where it's sprinkling along actually I don't see any, just up in British Columbia and at Bellingham, Matt Hitchman's hometown. light rain. Okay, so that's a picture over the continental U.S. at the surface. Let's go to the super peats at 500 millibars first. So here's the 500 millibar map from the GFS, with the GFS analysis on it. And as you can see, nothing's happening at 500 millibars today.
It's a whiteout.
Yeah, it's a whiteout. All right, so we'll look at the NAM instead. Doesn't matter.
That's 300.
We'll go, start at 5. We'll go up there eventually. Let's start at 5. So at 500 millibars, here's a picture of over the continental United States and Canada. So a couple of features of particular interest to me. Number one, we saw our circulation center in eastern Oklahoma in the radar depiction, and you get a sense that that's quite sensible. There's an upper level vortex that's sitting maybe a little bit further west than that over central Oklahoma and the Red River on the border between Texas and Oklahoma. And it's cold at 500 millibars, these locations. Amarillo's minus 21 at 500 millibars, which that's probably way below their average for this time of year, but certainly had something perhaps to do with the cold temperatures all the way to the ground. And then a broad trough over the northern tier of states, with the trough axis just about right to our west. And so we'll probably see increasing clouds as the day wears on. A very interesting little small scale but sharp feature on the British Columbia coast. These isotherms are every 5 degrees. So there's 5, 10, 15 degrees of horizontal contrast in temperature from the Queen Charlotte Islands to Vancouver at 500 millibars with a 95 knot jet right in there. So that's a very intense upper disturbance, and it's characterized by strong cold advection and cyclonic shear. There's probably strong subsidence right through the middle of that thing. I bet you have a little tendril of high PV from the stratosphere right along the British Columbia coast right now. But the scale of that feature is small in comparison to the broad anticyclone that sits over much of the western half of the North American continent, from the border with Canada all the way down to Mexico. And this is ideal for creating conditions that can enhance any wildfires that start in California. So it's a high impact synoptic setup right now. And especially when one considers that anticyclonic flow at upper levels, it continues to be anticyclonic all the way down to the Mexican border with Texas. So there tends to be upper convergence here, and we saw the high pressures in central Intermountain West. I think the highest one was now Salt Lake, 1,030 millibars. That stands to go even higher than that, increasing the offshore flow, in my estimation, along the coast of California. So they're just beginning, perhaps, to enter a period of some peril with respect to that risk. Okay, and then we can't quite see, here's the end of the Aleutian chain. One gets the impression this is the upper trough associated with that deep cyclone that's located still in a developmental position at 12Z, it looks like, because it's downstream, probably an upper trough axis there. Hard to know if this is cut off, but there's cyclonic curvature upstream and anticyclonic curvature downstream from the central position, and so one imagines strong upper divergence at the end of the Aleutian chain, or midway across it, which would continue the development. Okay, let's take a look at 300 millibars, just quickly, because it'll probably reflect the same features. Here's our very wavy pattern over the western part of North America, and it continues to be wavy over the eastern part. So this is what I was referring to. I hope to show you one map that's maybe hemispheric and click a couple of times ahead at something like 300 to 250 millibars, which you're going to see how that wave amplitude structure gets, the amplitude increases. So this is the next disturbance that will impact the United States. And then this is the one that we're currently dealing with the tropical cyclone to its south and east, and a strong jet roaring to the northeast across the New England states and the northern Ohio Valley states. And that's the situation in the upper troposphere. Could we look at 700 millibars, Pete? The often neglected 700 millibar level. Sometimes it shows some interesting thermal structures. That's why I always like to look at it. So here's our upper disturbance over the Red River in Oklahoma, Texas. And one sees a confused, perhaps, thermal structure, not so confused for the cold frontal portion of it, to the south and west of the minimum in geopotential height. Not so obvious what's going on to the north and east. And then here's our upper disturbance right at the southern portion of the British Columbia coast. And there's pretty strong warm air advection all the way across the southern plains of Canada and the western intermountain states of the United States. So this is all warm advection at 700 millibars. It's up to 0 degrees at Rapid City, nearly 2 miles above the surface. So that's pretty warm. And I suspect that's in the offing for us is going to be a tendency for warming. at least in the lower troposphere, over the next day or two. And let's go to 850 millibars. We don't see very strong flow across the mountains at high elevation yet. We will later on. And a consequence of its absence is you don't really see what we will at later times this weekend, a very strong lee side trough. The whole Intermountain West is a complicated mess at 850 millibars because many of the stations are actually at a pressure that's lower than that. But you can see a little bit of structure emerge over the western high plains or the eastern high plains and into Montana. These places are not quite at 850, so there's warm advection. There tends to be a little bit of a lee side thermal ridge that's developing here in the immediate lee of the higher latitude Rockies, and I think that's going to be a feature that has some influence on our weather over the weekend. And it's struggling to put itself together at 850 is really this weaker disturbance at lower tropospheric levels. We saw it was almost imperceptible as the sea level pressure minimum, and it's nearly so as an 850 millibar geopotential height minimum. Though the circulation is a little more obvious at 850 than it was at the surface. So, and it's an amalgamated circulation because you have offshore flow of parts of the Texas coast that are part of the circulation of the tropical disturbance, and then this extra tropical one to its north and west.
And you have that southerly flow. You see it, New
Right,
Orleans
yes.
and
Yeah.
and pinching upon those isotherms. That's for those, I guess, that you're Q2 class. That's what QS convergence might be in part helping to fuel the precipitation band.
Yeah, especially when there's a local wind speed maximum.
Maximum,
Right.
right.
Yeah, then you can get an axis of ascent that's kind of right along that wind speed maximum, and that can show up in the radar. Yeah, like it might be doing that right now. Okay, and just one last piece at 850. It's again relatively hard to see, but you get the impression there's a cold air stream headed down the coast of Mexico. Remember, we saw that kind of convective feature racing down the coast in the satellite movie, and that might be at the front edge of this cold air that's funneling down the peninsula at this point, and that's in the wake of the cold air outbreak that spawned the snow and various other things in Colorado as well as in North Texas. So that's a nice picture as well. What I wanted to show you next was, make sure I get the order right in my head. First, let me show you what the snowfall climatology is right now. The snow cover across the continental North America and Canada. Actually, it's more than that. So we'll go to the Rutgers page. They have a really nice snowfall map page. So this is the daily snow cover. I think it's assessed by a combination of surface obs and satellite. And so this is for yesterday, 24th, 2019. And so anything that's kind of round shaded is snow covered. And you can see that this is exactly what we saw, including the pixel that's probably the Amarillo area pixel all the way down there. So it's on the high terrain, mostly in the US Rockies, but not everywhere is just high terrain. And then snow in Northwest Canada, snow in parts of Alaska, Greenland, of course, and much of Eurasia and Siberia, Mongolia. Not so much in Mongolia, but a lot in Siberia. Let's take a look at how this compares to climatology. So you hit the chart, Apache, and where it's blue, there's a positive anomaly in the snow cover. So everything in the continental United States where there's snow on the ground is anomalous for this time of year. Goes without saying that's true in Amarillo, but in a lot of these other places it's anomalous as well. True also in parts of Canada, but not really a big bullseye of anomalous snow cover in Western Canada, just one spot. And then the western part of Alaska is suffering a deficit of snow cover. Interesting. That's not going to be alleviated in the next several days because it's going to get really warm there. So that I start to get worried about that as somebody who likes cold air and snow here in the central U.S. If this persists and spreads, let's say this deficit spreads, perhaps in the next week as a function of this warm advection that's about to occur on the border between Canada and Alaska, that kind of removes at least one element that can help produce cold air masses in proximity to us. And that is you take the radiative cover off the ground, take the snow off the ground, it's just harder to make the air cold. And the consequence of that is even if those air masses are moved southward, they're just not as cold. So it would give you a weaker early winter.
And the other thing, the coldest winters are usually when Alaska's warm.
Well, but when is it warm? It's when it's warm in Alaska in January, that's because there's a big ridge like this and then we're downstream of the trough. If it's warm early in the season, it makes me wonder if you can't produce cold air in North America. And then it doesn't matter what happens in January. So I'd like to, actually, I don't know the answer to that. It might be true that it depends on when it's warm in Alaska, what kind of winter you get.
The pattern is setting up like the so-called polar vortex last year almost with the
That's true.
cold air over Canada and warm air over Alaska.
No, that's definitely true. That is true.
Was that
And,
this early though, or was that?
yeah, that's what I'm
later on?
wondering.
Like, I thought that was, later on in the winter.
If you set the stage to produce cold air here, and then you bring the ridge trough structure like that, then you just move the cold air southward and it gets really cold. But that's at least the simple-minded way I'm thinking about it. And then over in the eastern hemisphere, there's positive snowfall anomalies over much of the boundary between Siberia and Mongolia, and even in central China. So there's some places where there's some snow that's not expected. Scandinavia has a little bit more than usual at this time of year, and then it goes into eastern Russia, or western Russia. Okay, then I wanted to show you something else with respect to cold air in the hemisphere, and that's this map that I got right down here, right there. So this thing is a time series. For some reason, I don't have data from the 1st, 2nd, and 3rd of September, but I started on the 4th of September this year. And then these three lines, black, blue, and green, are the blue one is the 1948 to 2014 average of the -5 aerial extent from September 1st all the way to the end, which is the end of December, but we're only out to the 24th. Then the black line is the first 30 years of that time series, 1951 to 1980, and the green line is the last 30 years of that time series. So from green to black indicates, or from black to green, I should say, indicates that this aerial extent has indeed shrunk in the last 60 years if you take the first 30 and compare it to the second 30, but not by very much. But this is this year's time series compared to any of those averages all the way to October 24th. So around the hemisphere, it's not regional, it's the whole northern hemisphere. And every single day has been below the average. So we're already accumulating a substantial deficit of aerial extent of cold air at 850 millibar. So that's interesting. And I have no sense at all yet from the statistics, or certainly no physical sense, of whether or not an early season deficit by this measure leads to something characteristic in the upcoming December, January, and February. It doesn't seem like there's any systematic relationship. But nonetheless, we're well below average. If you add up the departure from every day, we're well below average for how much cold air has been already produced in the lower troposphere in the northern hemisphere this winter. And I don't know, when you start to flood substantial land masses with warm air at the lower tropospheric level and reduce the chance for it to snow into early November, I think you make it even worse. So we'll see whether or not that's true.
It might be interesting to know also whether or not the accumulated deficits through a certain point in the year, regionally calculated, have an impact on particular other sectors around the globe.
Yeah, it would.
And then the map that you have behind that, the snowfall map, to the extent that you could look at snowfall deficit and see how it tracks with the 50 millibar cold pool.
Yeah, you could do a lot of different things like that. I think it's a really good point. Like if Alaska is running a deficit at certain times a year, what's the impact for a month downstream at another regional location? Yeah, that's a really good question. One last thing I wanted to show you is with respect to the cyclone at the end of the Aleutian Island chain. Michael, this is a surprise I've been saved for you. And that comes from, let's go back to our, whatever we had for our set of observations, Pete, the page that we get all our stuff from. Is that on this? Yeah, okay. So let's go to the Omega page right here. That'd be great, thank you. And this is from last night's run. So at a time when that cyclone in the Gulf of Alaska was at a pretty intense period. In fact, let's take a look at maybe this will come up as an FLI. I don't know if we can run them here or not. If we can take a look at that.
That particular application doesn't like.
That's okay, we don't need to do that. Let's look at the 0 hour forecast. So this is from 7 p.m. Oh, sorry, gotta go to the Pacific. I was thinking the wrong one. Scroll down to the North Pacific. Yeah, right here. This is how not to build a web page, anyway, for all you people who might have to do that. This was built in the 1990s, and so that's kind of the way that it is for me. And I'm not going to really change it because I can navigate it fine. Anyway, here's the end of the Aleutian chain, and the cyclone is, of course, right there. We saw it was quite intense. These yellow lines are 700 millibar quasi-dystrophic vertical motions. Every microbar per second. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 microbars per second. It's like 15 centimeters per second of synoptic scale updraft. Is suggested to be occurring at 0Z last night, right at that development period. And then here's the subsidence in blue. So that's the one I wanted you to pay attention to. The dotted lines are thickness from 500 to 900 millibars. They give you an idea of what the structure is underneath it. So you can see cold frontal structure right there, and then a warm frontal structure in there. So it's a nice picture of the storm. Now, the cool thing is you can split this up, and the split up is quite interesting today. Let's do the component of the total quasi-geostrophic vertical motion that comes from a long isotrope Q-vector convergence. So this is the same time, same level, but only a certain component of the total vertical motion. And I think it's about 2/3 or so of the total is provided in the ascent region by the long isotrope Q-vector convergence. And then a large part of the subsidences as well. You can see the structure is the same underneath it. Let's go to the transverse part, which is the more of the frontal vertical motions. And isn't that nice? You get this head of fairly substantial ascent right about at the head of the warm front, close to the cyclone center. And then this couplet, and it's actually a couplet for the warm front too, because here's the subsidence from it, here's the ascent. And then here's this couplet that stretches along a large portion of the cold front, subsidence behind, ascent ahead. So one can really see, even though the QG system is not particularly helpful for really nailing down frontal circulations, you still get some cartoon version of it from this partition. Now, the neat thing is the other piece I showed you, in fact, let's go down to another piece, Pete. Let's go to the subcliffe trend-birth omega. This is just the PVA by the thermal wind. And it looks a lot like the shear-wise piece I showed you before, although not so much in the subsidence region, but certainly in the ascent region. So this is all the ascent that's forced by vorticity advection by the thermal wind throughout the whole column, but measured at 700 millibars. Now, here's the cool thing, Michael. You can split the vorticity into its shear and its curvature pieces, and then calculate the same advection of each of those pieces of the vorticity by the thermal wind and see what you get. So they add up to this, the two pieces I'm going to show you now.
Prediction? Maybe prediction?
Yeah, make a prediction.
I'll probably be wrong. Most of it in the curvature.
That's correct. I've never seen a more tilted version of that I have in this case. So here, let's first look at let's do this. Let's look at the shear vorticity advection. It almost doesn't look like the same storm. There's the cyclone. There's actually subsidence in the cloud head forced by shear vorticity advection by the thermal wind, and there's weak ascent on the cold side of the cold front forced by it. That doesn't even look familiar. But then downstream, here's a nice example of a case that does look right? You can imagine here's a little jet feature in here, and so there's shear, positive vorticity advection by the shear vorticity, and negative. So you get a beautiful couplet. Not here. Look at the curvature though. Let's go to the next one, Pete. Unbelievable difference. So this thing is perhaps the first time I've really noticed this season a storm that's utterly dominated by the curvature vorticity advection by the thermal wind, and that's an intense cyclone. And so, we had in our proposal the fact that there's likely going to be different types of events that could be separated this way. That is clearly the case. This one is dramatically tilted towards curvature vorticity driving the bus. The shear is just along for a drunken ride. It doesn't even look like a no bus is on.
Right. Good thing it's taking a bus, though.
Yeah, right.
Actually, the bus driver is the one that.
Yeah, right.
So the question I have is, have you looked at the life cycle of this? Is this?
No.
So I was curious if you went back 12 hours or 18 hours, would you see something similar?
Unfortunately, on my webpage, and this is another caution for you who might design one, you'd like to have things that you could actually easily access from the past. I can get them, but I can't get them easily. So that's a great question. And in fact, it's prompted by this case itself. Yeah.
Well, that's interesting, but what does it mean? I mean, I know it means the curvature is dominating.
Yeah.
But so what? What does that tell you about this storm?
That is a good question. That's the question at hand. So it might be after one takes a look at, one categorizes a whole bunch of storms in a winter and finds there are a certain percentage of them that have this characteristic and a certain percentage that don't. Then you might be able to investigate that question. What is it about the differences here? Are there different frontal structures that evolve? Are there different broad scale environments from which they emerge? I don't know the answer.
You would expect that relationship to change during the life cycle.
Yes, it does seem, that's what I've always had as my bias, is that this thing does change, this relationship does change during the life cycle. But in what kind of systematic way and all that, I don't know yet.
Because we're, for the work that we're doing, we're interested in how the structure of the vortex, the midtropospheric vortex, as it evolves, and it's also associated with the upper front. How does the shape of it as it goes from generally you have an upper trough that's largely like a jet streak.
Hmm.
As it gets more compact, it becomes rounder, you're going to get more prominent affections that help the cyclone to develop. So how, during the life cycle of this evolving upper trough, what's its impact on the vertical motion? Or what's that impact of the vertical motion then on the development of the surface cyclone? So
Yeah.
it's a question that we're trying to.
Right, so you're asking exactly the question we're interested in. What does it matter? First of all, I don't know that it matters. It's interesting, that's for sure, but I don't know that it matters. But if it does matter, there's probably a way to track down why it matters. But first you have to separate the universe into these events versus the other kind.
But to some extent, the relationship between shear and curvature is just a frame of reference. I mean, you can change your frame of reference and get different shear, different curvature. Right, so.
But you probably don't get differences, you don't get a lack of distinction between the two, unless you really try. That's what it seems like to me.
Well, I mean, vorticity is vorticity, and you divide into shear and curvature. There are unique ways to do it, but well, in the frame of reference relative to the ground, that's not the unique way to do it. But if you did do it in a unique way, I wonder if that would show you something else,
Maybe.
that's more
Maybe,
standard.
maybe.
And what's the frame of reference you'd have to do to take a purely shear vorticity component and make it all curvature?
I don't know.
Well, that's what Luke did. I mean, that's where he got that, and that's
Right,
what he did in his thesis.
Zeta squared
So that-
minus the total difference is an interesting offline conversation, I think.
Right, we should do it offline,
Yeah,
but we have the formula, so you can do it.
Okay, that'll be interesting to.
Yeah, because it wouldn't be hard to implement it, I suspect. And it'd be kind of funny to see what it looks like. Because then if this is an example case where you just do the regular pedestrian partition of the vorticity, and then you do a more sophisticated one, do you still see anything interesting? Or are those things the same? That would be a very interesting thing to
When I
pursue.
show those inertial frequencies, that's the formula.
Yeah.
The inertial frequency separates out the curvature part.
Yeah, that would be fun to try that, to see what we get. So, but this is the first time I've seen a storm, actually in a number of years, that is this tilted to one versus the other. It's usually about a 60-40, 70-30 split.
I thought that's
Like
what you were gonna
90.
show. I was like, okay, well,
Yeah,
but this is actually, I mean, it's almost, 90-10 or even.
yeah, it's way, way
110 minus 10.
over. Right, it's way overboard. So that's what I have for today.
After
So.
this, it weakened.
Sorry?
After this, it weakened. This
Um,
was yesterday, right, at 0.
yeah, I don't know what happened after that, so.
We could look at the
yeah,
different.
We can go to
just-
the 12-hour forecast. Let's do it just of these two species. So this one here. So that's what it looked like in the shear vorticity affection. Let's see what the curvature shows. That's right there. Yeah, weakened, but still the predominance of the curvature remains a statement that you can make through at least 12 hours into this forecast. And we could keep on going, but there may be no particular reason to do so. And as the storm occludes and gets really wrapped up, both of these things begin to vanish. And so one of them is already close to zero, the other one's headed to zero, so they're going to start to look a little bit more similar. So, I wanted to show one thing in the forecast. Can we just go to go to pivotal? You already have pivotal problem lined up, right?
Yeah, last.
We're going to look at the 250 millibar wind speed, and we'll put it on a different. Let's see, upper dynamics. I don't know where they are either, Pete. Otherwise, I can tell you.
Yeah, there it is.
That's good. That'll work. And then let's go to a different location. So not continental U.S. Let's go to continental, and then do North America, and you see it. Or actually, hemisphere is even better. Can we do that? Hemisphere?
Click on that, yeah.
Yeah, okay. All right, that's great. So here's a picture of the 200 millibar wind speed and geopotential height, and this is at right about now. So here's the waviness I'm talking about in the flow. So let's go ahead a couple of times and watch how the amplitude of these waves over and near North America increase. Look at that. Isn't that dramatic? This flow gets really wavy in the Western Hemisphere. Then there's even this big wave down here at about the meridian. But this is an exceptionally wavy flow, and I think that has ramifications, and I don't want to spoil the party. I'm going to leave that to Michael, but you can see what's going on here. One of them is, boy, you're going to clear the skies out in northern Canada where the sun doesn't come up anymore. It's cold. So, okay, so I wanted to show you that too.
Okay. While we have this map, let's go to a surface, if there's a surface version of it. No, we don't have that. So actually let's look at regions again. And let's go over to Europe. Something I forgot to look at and scroll this pretty good. That doesn't quite.
Oh, yeah.
Let's go to Africa.
That doesn't
Almost do it, but let's look at the surface precipitation. This let's go to 0 hours, please. So it's kind of interesting. This barely shows it. This little cyclone right here originated over from an upper level cutoff low over the Mediterranean. They call these metacanes. These are almost tropical. These are cyclones that have tropical characteristics that occasionally, from time to time, do develop over the Mediterranean Sea. And I guess this morning I had 55 knot winds out over the eastern Mediterranean, moving just north of Egypt into the north of the Suez into Israel and Jordan later on this afternoon. But this is a pretty tight, very close circulation that looks almost like a tropical cyclone. If you looked at the satellite imagery, it had sort of banded structures. It's kind of interesting phenomena that occurred over the eastern Mediterranean over the last couple of days. And it'll dissipate once it makes landfall. Again, these happen occasionally. I know, Greg, you've looked at some of these types of disturbances in the past.
Yeah, they're subtropical winds.
Yeah.
Effectively.
That, they can have something that looks very tropical. That's probably a tropical cyclone just east of
Tropical
West
storm
India.
that's supposed to develop into Cat 3.
This
And
one.
then curve towards.
So, but that wasn't something I was initially wanting to look at. But if we could go back to John's page for a second, I want to look at over North America, the vertical motions, this QSQN, because it was kind of curious. We want,
North America's top.
what's the top one?
Isn't it obvious?
This is easily navigable.
Yeah, right.
Just like the river, the Nile, I guess. Trying to find the source of the Nile. Okay, and then we want to look at do you have a QSQN?
Yeah, it's
position?
shear-wise.
Shear-wise, okay. So we're going to look at the shear-wise at 12 hours in the forecast. And this doesn't quite show up. I guess this band right here is kind of coincident in part with the band that we saw in the.
Yeah, it is. Yeah, you're right.
So this band right here. So this is kind of suggested. It's often a common scenario when you have an upper low interacting, the circulation around it, interacting with in the lower troposphere at least, the south or southeasterly winds, impinging on these isotherms with a local maximum, almost jet-like feature coming up through crossing the isotherms gives you this pattern of vertical motions. That's
Yeah,
kind of
the
neat.
bullseye is from the upper wave, but that
Right.
little appendage is what you're saying, I think, yeah.
So that shows up really nice if you recall the radar imagery. Other thing I wanted to look at, so John inspired this in the discussion, was let's look at water vapor imagery for the West Coast to see that upper front. That should probably show up pretty well.
Yeah.
If there's been any historical subsidence in that. I guess you could see. Oh, this jumps unfortunately.
Yeah, that's
But,
a problem.
in this region right here that's a little bit darker, there's a region of sort of historical subsidence over time. But the feature that John was pointing out that's moving into British Columbia today is probably going to be responsible for perhaps our first accumulating snow if the GFS is correct. And we'll get to that.
You can kind of see like the the cyclonic motion in the first part turning into cyclonic motion in the second. So anticyclonic right there, turning then into cyclonic.
Right, so I think this is the whole passage of this feature as it moves
Yeah.
toward the east.
Unfortunate.
Right.
Yeah.
But also you'll see, look at the tilt of this structure right here. And then now it's almost neutrally tilted. We'll see that, and this is going to play a role also, similar sort of pattern once this moves over North America, over the Intermountain West. Last thing I wanted to look at before we get to the forecast maps is you have satellite imagery, Pete, that shows different colors for different, I don't think what the term is. But I'd like to look at what's moving off the Gulf of Mexico right now with the cold advection. We can pick that up.
We're gonna look in the air mass RGB.
Maybe the air mass one. I don't look at this on a regular basis. So this is this developer. Is this today? So check on that. It is. You'll see some of the saw some imagery earlier. I mean, this is where that boundary is beginning to trigger convection. the cold advection off the continent, but it doesn't really show up well here.
Thinking of water vapor image instead.
I don't think it was water vapor, but anyway, this actually shows, interestingly enough, the development of this tropical cyclone. This is TC number, possible tropical disturbance number 17. We can quit this, we'll just go to the NHC page just to get a little bit on the stats on this particular developing situation. And maybe it's actually a depression now. Let's see if it's not even a potential disturbance. You can keep track of it, so if you want to go tropical depression chasing, it'll be passing just south of Champaign-Urbana and central southeast of it sometime later on this weekend. So if you want to drive out and experience tropical cyclone conditions or post-tropical cyclone conditions, that's the track you want to look at. But yeah,
Think
the
of all the
biggest
great
concern
places
from
you
this,
could visit too.
what's that?
Think of all the great places
yeah.
you can visit too while you're doing it.
It's just going to be amazing. Get out there and enjoy it. Be safe. But here's the rainfall forecast. Again, they're looking at from 2 to 4 inches of rain over parts of Mississippi. Not enough in southeastern Alabama, unfortunately, but maybe the track will change, or maybe it'll be edited by someone. But I think the winds are, the biggest impact is perhaps going to be the precipitation. But this is going to, this is as a depression, has winds about 35 miles an hour. The reason the Weather Service isn't really concerned about it becoming too big a deal is that the cold front that's moved off the coast is going to kind of squelch or sort of halt any further significant development of the storm. But there's always the possibility of severe weather as it moves onshore. But the biggest impact is probably going to be the precipitation.
I kind of wonder if 10 or 20 years ago, we would have
You
called
called
this
it
tropical at all.
right.
I mean,
That's
it looks like a classic Gulf low, extratropical low.
Right. Before that, the front moved out yesterday. It looked kind of interesting. Oh, question, please.
Oh, actually, parts of Alabama just got out of the tornado warning.
Okay, so they've actually had some severe weather in Alabama with this well ahead of the storm. Next to that point, let's look at go to SPC. Maybe we can see some. Yeah, thank you.
Oh yeah, look at that.
Yeah. So there's some severe weather well east of this, in the northeast of this cyclone. So that's something that is going on today. Actually, the tornado watch has been issued for this region right now. And just the summary of the discussion here, they've analyzed the warm front again, well ahead of this system. It's way down.
It's right in that spot that you were talking about
With
with
the
the
southern
US.
flow.
Yep.
Yeah, with a southerly
Right,
flow
yeah.
going right across this. This is a place where you expect significant ascent to be occurring. And I guess with that boundary there's shear across frontal boundaries of this sort. So that provides some turning to the wind, some velocity. So that in fact acts as a focus for possible severe weather. So it's a good catch.
Yes.
To note that. So I don't want to diminish the importance or the significance of this disturbance, but this is, it's unclear if this is directly related to the tropical cyclone. It's certainly the upper low is providing of an environment that's capable of supporting ascent, and the moisture from the tropical cyclone, the water vapor flux northward, is certainly getting, I think, involved.
Yeah, I think it's a collaboration.
It's a typical place relative to a tropical cyclone for there to be tornadoes, if the tropical cyclone is a little bit closer.
Right.
But the reason it's occurring is because of the southerly flow off the water,
Right.
southeasterly flow, and because it comes off the water, it's frictionless almost. It's just above the boundary layer, and then below that, friction slows it down, so that creates a positive velocity, and then that's conducive to tornadoes.
And also the fact that you have that frontal boundary there is also another source for that. So let's go to the pivotal page, and I'm going to start off and we'll go back to North America, and we're going to start off with the tropopause maps and look at the evolution of that, and then see what it means for the surface.
963, I think it's the end of the ocean.
Yeah, there's that big cyclone John was looking at earlier. Here's our Gulf storm. We're going to go back to the North America. Let's go. This is not all that, is it? National. Yeah, not in the US. Okay. So the things I like to focus on, we're going to step forward in time, but we're going to watch this purple area. Again, how do we look at these maps? And we're looking at, this is potential temperature. So this is a conserved variable along the surface of another conserved variable, which is a surface of constant potential vorticity, which basically combines the effects of the stratification of the atmosphere, how stable it is to vertical displacements, with another variable which measures effectively the stability to lateral displacement, which is the vorticity of measure of crudely the spin in the atmosphere. So as we step forward in time,
Point out locations on there, that map's a little hard to see.
yeah, so here's Wisconsin. Here is that feature approaching the, it's over British Columbia. It was making landfall earlier today. And we saw a little bit of some sprinkles there in Bellingham and other areas that John was looking at in the upper front. So we're going to advance this forward. Let's go ahead to 18 hours in the forecast. Okay, so you can see this boundary, which that goes from really cold temperatures, effectively lower potential temperatures, to higher potential temperatures. You can see the little bands that are embedded in this. Here's the upper low that's over Texas, so it's because the tropopause is locally depressed. We have this feature right here, and let's advance a little bit further in time. We're going to focus on this first, just to get through the weekend. This upper trough, we go ahead, we go to 36 hours. It advances northward. It's being advected by the flow northward. We have the remnants of our depression moving northward as well. And so it's possible we'll see downstream of this trough. This is sort of a traditional trough-like feature. You can see the winds turning cyclonically around it. This is going to be a favorable alignment for us to get some precipitation, particularly in southeastern Wisconsin. I think where they can get anywhere from maybe our area getting for 1/4 of an inch to maybe 1/2 inch to an inch of liquid precipitation. We'll look at the surface map in just a little bit. But the really interesting feature that I want to focus on, this gets us to tomorrow evening, is this upper trough that's finally kind of coming together, but has a very odd tilt initially. Let's go ahead to 48 hours just to move forward of this. Tilt has changed a little bit. And by the tilt, I mean just relative to, if you imagine just an XY axis, it's not perfect. This has sort of a southwest to northeast tilt. As we go forward another 12 hours, we'll do this very slowly. At least in this forecast, this trough feature begins, the tilt begins to slowly change, particularly the southern part of this. So again, this is a trough in the atmosphere. Downstream of these troughs, particularly when there's a lot of curvature, changes in curvature, you can get significant, you can get vertical motion occur. Let's go ahead a little bit further for the 12 hours. Now we're beginning to get this going from northwest to southeast to more north-south. And we're downstream of it. This is a region where we might expect to see some ascent. Let's go ahead let's go to 90 hours. Oops, that's too far. I'm sorry, we're going to step through this carefully. So to 72, go back to 72, and then go to 78. Okay. This is getting nice and a little bit more robust. Downstream of it, we can see there's local maximum curvature here, not much here, so that the ascent is going to be developing used to this.
Yeah, look at that ominous upper vortex that's sitting over Saskatchewan. Yeah, that's
Right.
awesome.
That's chilly. That's very low depressed tropopause. This is a region of cold air beneath this, but it's also ascent ahead of it, which is, as the ascent occurs, it helps cool the air, so when the trough arrives, it's already cold. 84 hours. This is zooming toward us. Again, it looks very innocuous. That's a small scale feature. Look at this big flopping cyclonic circulation here. All right, let's go. We're going to stop for a second to the surface map.
Michael, before you go there, can I ask a question?
Sure.
If you go to like 48 hours again,
Sorry, should be looking out. Look at the screen.
do those like smatterings of higher values, do they have like physical significance in there?
I'm going to say probably no. I don't know how they actually construct this map. There are a number of ways. There's an interesting paper on it that gives ways of constructing these maps. But you can basically plot potential temperature at every single isentropic level from the start of your data set all the way down and just superpose them. And so these could be blobs where there's been perhaps deep convection or something that's occurred, or you can start from the bottom up and then hide all these things. And so it depends. I think this is a top-down construction of this map. Or you can interpolate, and that can give you all sorts of weird things where the tropopause is undefined. But very small-scale structures like this, I would say, aren't important. This has at least enough. It's been resolved by lots of grid points in the model. I would focus more on the smeared out version of this. Let's go back to 84 hours. It's kind of fun. It's exciting. Trough is just over on parts of Missouri, and then we go to the surface map with precipitation. Here we go.
Oh, yeah.
And so downstream of that upper trough, if you look at the thickness field, you can see some evidence of some curvature in it. Evidence of an upper trough. We'll look at the more standard 500 millibar map. But we have the surface or lower tropospheric baroclinicity, where there's upper trough approaching. If you use for the Sutcliffe Trenberth formula, the Omega equation, you're going to see downstream of that upper trough is where you expect to see ascent, is advection of PVA by the thermal wind. This is the nice region for that. Our thicknesses are just marginally cold enough for frozen precipitation. We can actually do a sounding at this location over Madison, a little bit further north of us, on the warm side. But here we have, in the sounding surface temperature 37, dew point 25. If it starts precipitating, it's going to wet bulb to pretty much worry about freezing or something.
Right.
So this is really good for snow. Most likely precipitation type, if we were to get precip, is snow. Let's just advance this ahead 1 6-hour period from 84 to 90 hours. Precip has probably already started. We're saturated in the column. We're down to 30 degrees. This is at
Midnight,
60 midnight Monday night, when we'll probably have some ground's cold enough to support accumulating snow that's been relatively warm. It's been chilly recently, so maybe we'll actually get a little bit. And we go back to the surface map at this time. We can see the snow is just about over by that time. So this is a 6-hour period, Monday night or Monday evening into early Tuesday morning, when we can get a brief period of snow as this wave comes through. We'll see it, if we'll go back to Triple's map, we would actually see that this wave is beginning to sort of get smaller and smaller and get kind of stretched out as it continues to advance in the flow.
Point out.
Yeah.
This looks like an almost textbook case of how a negatively tilted wave transfers its energy into the zonal flow.
Right, so it's
You see
losing its
that
energy.
wave shrinking
Right.
as it,
You can see it's even just smaller now than it was earlier. So you can follow this wave as it streaks through in the flow. It just probably helped me to accelerate the flow then, because it's this transfer of energy, barotropic conversion of energy from.
from eddy to zonal.
Right. So this is just about done. And we have another wave upstream of this, which we'll see how it develops. But here's the thing that's really interesting, and John and I were looking at it this morning. So this is a period, this is Tuesday. Let's go back to the surface map, and I just want to show you the fact that this is not, a slam dunk big snowstorm. If we were to look at, first of all, just go back 24 hours ago. So a forecast from yesterday morning, that's what we're looking at. Okay? We don't even, you can barely make out those parts of front way down here. A little bit of a trough over Arkansas, but this is not even in a region where we saw the cyclone. If you go advanced time forward, Z forecast from yesterday, we're beginning to see the first hints of that. That's well to the south. You go further in time. 0Z last night kind of begins to back off a bit. 6Z looks more robust, and then we go finally to the forecast. So something's beginning to emerge in the forecast. What about other models? Forget about the GFS and some other ways of constructing this. Go to the Canadian GDPS. Okay, well, nothing at that point in time. And again, some of these you could trace to wave. Unfortunately, we don't have time to do that. But to also just highlight, if we step forward in this forecast from, let's go back to the 12Z forecast from yesterday morning. Sorry, for this model. I think this is the one we were looking at earlier, John. And if we step forward, what happens?
Oh, yeah, you're right. This one.
This is still not it, is it?
But it's a longer period of snow.
Right, let's go, just keep going forward, keep going forward. I think it's the next. But we'll also show there is going to be, with this increasingly wavy pattern over the Pacific, I think this is going to highlight the possibility of really significant differences.
Oh, yeah, look at that.
Yeah, so this was the next wave that comes through that just keeps us in a long duration snow event. This will probably be all snow in this small forecast.
Halloween.
That could be a Halloween snowfall. But let's go back to the height of that storm, go back one quick. And compare it with the 12Z GFS. For the 12Z G, just keep the same model, just see how it's changed. Cyclone's located right there, gone. There's something weird going on. If we go to the GFS, nothing.
Well,
This is probably it, but it's further to the east. So lots of uncertainty coming up in the forecast for next week from anywhere from, it looks like perhaps some accumulating snow on perhaps Monday night into early Tuesday morning. And then the question is what happens later in the week. But this is some pretty chilly air that's going to be over us coming up. So the forecast, this is something a little fun. I saw this, the Weather Service put this out. So on Twitter, you can hit return on that. You want to know what costume you should go as during Halloween. They have this, you take the first letter of your first name, the first letter of your last name. So for John, it's clear, it's Nestic Snow.
For choice.
I had
For
nothing to
me,
do with this.
For me, it's easily spooked
Snow.
snow, which actually works out.
That's perfect too, yeah, that's right.
Anyway, so,
You
Have your
open
fun
it
with
up, so we'll see it.
okay, we open, oh, we can click on that, to open that
There's the bottom.
I don't know how I would do logistics.
Wow.
up. Yeah, Zoe Brooks-Lipton would be plotting sleep, so I don't know.
Plotting dew point.
Two places, right, yeah.
Yeah.
Anyway, this is something that's not really weather related, but weather service put it out, so I figured it was fair game for weather. Anyway, thanks, John. Thanks everyone for coming. Thanks for the questions and suggestions on the back, noting the severe weather that's occurring down in the southeastern part of the United States. But again, for the weekend, we didn't really go through the first part of the weekend. I skipped that with a disturbance, but we're probably gonna see some rain during the day on Sunday from that, the remnants of that depression as it goes by to our southeast. Heaviest rain over the parts of southeastern part of our state. And then the next shot for precipitation could be snow Monday night. So watch out for that. And we'll see next week if that actually verifies. Anyway, have a wonderful weekend. See you later.
Thanks, Michael. And to you. Turn out the president would be a scary flash flood.
No.
Hey, John,
Yeah.
have you looked at the paving for this season?